Hello, good afternoon. I will be discussing to you now the lesson 3 processes. I have uploaded this into your, this is the same module that I have uploaded in your Google Classroom. And in the previous video discussion, or in the previous lecture, we have been discussing the foundation of operating system and the functions of an operating system. And now moving on to the most part of the operating system, which is the processes. That is one of the most important topic of operating system, the processes and the process management, or the process management. And uh, I I want to discuss also the introductory idea of what is processes and what are the threads, or what is thread, because most of the time the processes and threads, which I uploaded also in your Google Classroom, are quite confusing at the same time. So I will be discussing processes, and maybe later on I will also discuss what thread is all about. But before that, let's just first understand the basic of how the program is being developed, because as we all know, you are doing your programming already using any high level programming languages you have. So to make a program, we all know that the first thing to do is to write it using some high level programming languages. Let's say we have a C++ or Java or something like that. So uh, if you are going to write it in high level languages, all we need is to have the C++ or Java. But we all know also that uh, computer cannot understand, even if you write it in a high level languages. We all know that computer cannot understand, not unless we use binary, which are the 0 and 1. So the program has to be converted to binary code. So for that, we're going to use a compiler. You compile your program, and the compiler helps you convert the program into a machine language. Let's say, of course, we all know how to convert from binary to from binary to decimal, and decimal to binary, and using the ASCII code as well. If you're using the letters and the other characters, you have to convert it into the ASCII code, for so that your machine or your computer can understand, or it will be understandable by the machine or your computer. So after that, you have your program converted into binary executable code. So let's say, for example, that's why when you have your files with you, di ba naman tayo mga .xc, that is that executable. We have that doc and so many other things. So when it is ready for execution, when the converted program, it becomes binary code ready for the machine to understand. It is not enough to have the binary code for the program to execute. Dili siya enough nga converted lang siya, or using the compiler it is already converted into binary code. It is not enough for it to be like that only. It is important that once it is loaded in, or how are you going to load it into the computer, is it has a lot to do with your operating system. So the operating system will load it into the memory once it is being converted. So from the raw program, using your high level languages, using the compiler, you convert it into a binary executable code. And then using the operating system, it will help you, the convertible code will help you load it into the memory. It is the main memory, or the random access memory. And for the program to execute, it needs some resources of the computer system. So who will give you the resources, who will to allocate this into the CPU? So that is the operating system. So the brain work behind all of this, it is the operating system. So the operating system will help you in those kind of processes. It will help you load the executable code or the .exe into the memory and allocate it to the resources. Resources are the I/O, the input and output resources, or the input and output devices. And then program will begin its execution. So the moment the execution will begin at that instance, we call that as a program or a process. So meaning to say, a process can be called a process once the program begins its execution only. So when the process start execution, at that time, we call it a process. So if it is not executing, meaning to say it is a passive entity, meaning standby lang siya. But when the program starts processing or it starts executing, so that's what we call process. So ang nakabutang dire, a process is execution process must progress its sequential fashion. So again, the process can be called a process once the program is being executing in your computer or in your machine. So the part of the process, so what are the part of the process? So here in the illustrations, we have the text section, and then the current activity including the program counter where is the processor registers already, and then the stack where it contained the temporary data, the function parameters, the return addresses, and the local variables that you are using within your program or whatever program that is being inputted or that is being loaded into the system. And then the data section containing the global variables, and then the heap, which is the containing memory of dynamically allocated during runtime. So again, when the program is on standby or when the program is not starting its execution yet, that is it's not yet called as a process. So it is called a passive entity in stored in some disk, or is stored in a secondary storage. So again, secondary storage are those kanang mga hard disk, flash drive, and so on and so forth. So the program becomes process, it is called a process when executable files is loaded into the memory. Once it is being a process, or once it is being executed, that is what we call process. So execution of program started as the graphical GUI mouse click and command line entry of its name, etc. So what are the process state? So mao ni siya ang gitawag na diagram of a process state. So there are 1, 2, 3, 4, 5 state or how the process is being executed. Mao ni siya mga different state of processes. So in this video, I was hoping I could give you illustration about this using row description about, but let's try to use this illustration here. So again, we have diagram. So we'll start with there are the different states. So mao ni siya ang new. When in this part, I'm going to illustrate to you the process state or the foundation diagram. This is what you call kanang gitawag nato nga later on ma-discuss pod ni kanang gitawag nato nga FIFO or FIFO kanang first in first out nga process. So this is what we call the first in and the first out process state nato using the 5 or the 4 state. So the first is the new. This is the new state. And then if the process is a new state or about to create or about to be admitted, about to be admitted, it doesn't mean that the program or the process has been created already. So kani siya naapa ni siya matawag nato sa secondary storage, meaning to say wala pa siya naabot dito sa imong main memory, because as we all know, once nga naapa siya sa secondary storage, passive pa man na siya, meaning to say no execution, no processes were being created. So naapa siya sa ingon pa nag-ung-ung pa siya. Now this will be peak after there is a new, once you have the process already converted na to ang program into an executable code, once it is being processed already, gi-ready na siya, gi-load na siya into the main memory or the RAM nga mutabang sa imuha sa pag-process sa imuhang program or mo-process of what data you want to input it or to want to load into your computer. So naa na siya sa ready. So once it is ready, muna na to matawag nga admitted na siya. So the operating system helps you load those program that you want the main program to be admitted. Now after this one, the next state is you have to go to the ready state. So diri na ta sa ready state. So new, admitted, and then ready. So after sa ready state, it means that the process is ready to run, meaning the process is getting ready to run. So the main memory, it will be going to your CPU. So after this, it will go to the running state. So kani dire running state na ni. Running state. So once it is in running state, this state knows as the schedule dispatch. Mo na gitawag nato rig scheduler dispatch, or in i-allocate niya sa imuhang CPU when he is being processed. So makita po din ninyo when you have your computer or we have your laptop, try to click Control Alt Delete, makita ninyo dito na yung mga running, what's the program that are running, pila ka percentage sa CPU ang gigamit. Just try to click Control Alt Delete and then you can see what are the programs or what are the processes that are running currently in your system. So once you are in the running state, meaning the instruction within the process are being executed, meaning kadtong mga processes or kadtong mga program that you are trying to your system to do or to present what do you want what your program wants to do, diri na siya nagdagan sa running. So the processes are being executed in this part or in this state. So a running state is where it can go if everything will go smoothly. The process CPU, if like gigikan sa new, and then the program is being ready and it will go onto the running state. After sa running state, if the process is being smoothly gi-process na siya, and if everything is going well, moadto na ni siya sa terminated na state, meaning to say you're done, finished na, completed na. So the process has been terminated. Now if the process have been completed, but there are request of process nga mogamit siya mga IO events or mga IO nga mga processes, it will become a waiting state, meaning to say naatay gitawag nga mga state or naatay gitawag nga mga resources for it to be completed or for the IO devices to be utilized. So now suppose at one point the processes are running and executing in CPU and also but the process wants to use some IO devices. Let's say for example, ang program nimo or the one that you are making, the program that you are creating wants you to display something on your monitor instead of terminating it at one point. So mura siya muhunong diri sa IO and then kuha siya sa waiting state niya until ipakita niya kung unsa nga IO devices or unsa nga IO devices ang imong request for your program to be completed. Right? So gikan sa running state, let's say for example your program is Hello World or whatever program you want it to display, i-ready niya, ipa-run niya. Now if there's no need for you to get the output, i-terminate niya. However, if the CPU or if the running state is calling some IO devices nga may ginid sa imong process, it will be on the waiting state. This will be the operating system will allocate or will assign which IO devices you want to use. Then after that one, i-complete na niya sa IO devices that you asked. or that you want your program to be displayed, diri na niya ipakita, and then it will be a continuing process because as we all know, a system or a computer in a computer machine is a multitasking process or a multitasking process state. So pwede rin na siya magbalik-balik become until it become or until the programs that you want to do gives you the satisfaction. So either i-terminate nimo, your program has been already done, or you can run the program and call some IO devices to help you complete your program. So that's the basic 5-state model of process. So for any process, almost in every operating system, this diagram, kaninga diagram, would be there, and this process would go to this 5 states. So for every program nga gamito nimo, for every process nga gamito nimo in a computer system, kanigid siya ang this simple diagram of a process state will always be present. And in this diagram also, there are sometimes manggod, there are kanang you cannot just forcefully pull out or remove any processes. So either you can stop it from running or it will be terminated. The process once by the IO devices, you can go waiting or you can go to fully terminate the state. So ang kaning program kaning naadiri nga tunga nga kaning naadiri nga tunga nga arrow, kung wala ni siya, so mo ni gitawag nato nga known preemption. Pero ug naa ni siya, mo ni gitawag nato nga unknown preemption, because sometimes there are some request priority within the priority sa imuhang state nga mo enter up ang kanang iyahang gitawag nato nga process. So if there are processes that there are two types of kanang gitawag nato nga preemption, the known preemption and the unknown preemption. So that's why there are some processes nga instead of from ready, instead of mo interrupt siya, and then he will be doing the process again and again. So mo gitawag nato diri nga interrupt. So later on, I will also discuss to you the process control block in the next video. So I hope you understand somehow, bisan gamay, the processes. What is the processes? The point lang gid ani is how anong unsaon nato pag-define ang processes in an operating system world. So asa dapit mo inject anang processes. So again, ang process is when the program is being executed, that's what we call process. Pero ang program gali is naka-standby ra siya without making it into the main memory, without making it into the central processing unit, meaning to say that is not a process yet. We can only call a program a process if it is being executed, or the program becomes a process when executable file is loaded into the memory. So again, memory is the main memory and the random access of your CPU or of your computer system. So again, I hope you get something out of this, and just let me know if you have any questions. And again, thank you for listening.